as the question says, a simple pendulum of length L having a bob of mass m is deflected from its rest position by an angle theta and released. The string hits a peg which is fixed at a distance x below the point of suspension, and the bob starts going in a circle centered at the peg. Then, assuming that initially the bob has a height less than peg, show that the maximum height reached by the bob equals its initial height. And then if the pendulum is released with theta equal to 90 degrees and x is L by 2, find the maximum height reached by the bob above its lowest position before the string becomes slack. Then find the minimum value of x by L for which the bob goes in a complete circle about the peg when the pendulum is released from theta equal to 90 degrees. Now what's happening in this question is that this pendulum is released from an angle theta. It comes to its vertical position like this, almost doing a part of SHM motion, comes here, and this is a peg or a hook sort of thing we can say. So this string comes in contact with this, and what happens is that in the next part of this motion, this becomes a circular motion about this peg. That means this much of the length, that is x part of L, will be along this peg, while the rest, that is L minus x, will make a circle on which this simple pendulum will actually move, right? So this is all happening in a vertical plane. So let us work out this problem, proceeding with the part A, in which we need to find out the maximum height. Now friends, here right now let us take the points, if this being the initial point A and the maximum height reached by this is point B, then so the total energy at A must be equal to total energy at B. Now what's total energy at point A? It will be the kinetic energy at A plus potential energy at A. And similarly at B, it will be kinetic energy at B plus potential energy at B. Now we all know that as this bob will reach the maximum height, its velocity will obviously be 0. That means that the kinetic energy will be 0. So it will be 0 on both the sides. So we can say that the potential energy at A equal to potential energy at B, and if we take this to be the reference, then we can say that the height will be the same. Hence the maximum height for the bob will be equal to the initial height, because the potential energy needs to be the same, right? Now proceeding with the second part of this question, in which they have assumed that the theta is 90 degrees while x is L by 2, and we need to find the maximum height reached by the bob before the string becomes slack. Now slack is when the tension in the string becomes 0, right? So let us draw the diagram of this question, in which it will be roughly like this, hanging from here, this being the peg, this being the point where the tension becomes 0 in this circular motion, right? Now let this angle be alpha with the vertical, and this is actually the height. It has come down because it has been released from the angle 90, right? So framing the equation here, we can easily say that half mv square, if this point is assumed to be point C, then it will be vc square minus initial kinetic energy, which was 0 because it was dropped from here, equal to the work done by the gravitational force, which will be mg into change in height. Now this difference height h will be this thing, and this will be L by 2 minus L by 2 cos alpha, right? So from here we can write it out that Vc square is equal to GL into 1 minus cos alpha. Marking it as equation number 1, let us proceed. Now here we will be having bob like this, so mg force will be downwards, so the cos alpha component will be there along the center, so the centripetal force will be mv square by r, where r is L by 2 over here, equal to mg cos alpha. Marking it as equation number 2 and equating Vc square from equation number 1 and 2, we get cos alpha equal to 2 by 3. Now we need to find the highest position, because they have asked us the maximum height reached by the bob. So we need to find this position from here, from the lowest point. So all this height, capital H, has to be calculated. And so we can write it as capital H equals to this distance L by 2 plus this distance from this triangle as L by 2 cos alpha, right? Putting the value of cos alpha as 2 by 3, this gives us as 5L by 6. So this is that maximum height. Now proceeding with the third part of this question, which is find the minimum value of x by L for which the bob goes in a complete circle about the peg. Now when will this bob will complete? This will be when this alpha becomes 0, that is, this tension becomes 0 at the highest point, because after that, that momentum will make it, rather compel it to complete the motion. So what happens is that this alpha actually becomes 0 in that case. So writing the equation as the centripetal force being mv square by r, and the r will be L minus x, because this is the radius, this is L minus x, equal to mg cos alpha. Now here alpha is 0, so cos alpha is 1, giving us the equation mvc square over L minus x equal to mg, and marking it as equation number 3. Let us now apply the work energy theorem between the points A and the point C, which is the final point. Writing it down, we can write half mvc square as the final kinetic energy minus 0, the initial kinetic energy, into mg into height. Now what the height will be? Now height will be this whole length, that is L, minus when this will reach the maximum height, it will be L minus x. This will be the x part, L minus x, plus this will be L minus x. So twice of L minus x will be subtracted, right? This will be twice of L minus x. So from here we get Vc square equal to 2g into 2x minus L, and marking it as equation number 4 and equating again Vc square from equation number 3 and 4, we get x by L equal to 3 by 5 equal to 0.6. So the x by L should be at least 0.6 for this bob to complete this whole circle.